Hello, today we're gonna talk about proton motive force, also known as protogradient. This is an essential part of ATP synthesis. ATP synthase, also known as complex 5, use this proton gradient to do chemical work and convert ADP and phosphate into ATP. But there's a big question: how this proton motive force appears? What do you need to create this proton gradient? I'm gonna take the electron transport chain as an example, and if you see in my screen a membrane, and that it's separating the intermembrane space and the mitochondrial matrix. Why this is important? Okay, so to create this gradient or this electrochemical gradient, you need to have a closed membrane that separates both sides. Okay, so let's go to the electron transport chain. The electron transport chain has different complexes that are able to pump protons into the intermembrane space. So all of these complexes that I have here have the same ability. So that's the reason why, if you notice, I'm missing complex number 2. I'm not putting it in here because complex number 2 doesn't pump protons into the intermembrane space. Just notice that it exists and it has other function, but for why I'm trying to explain, I'm gonna skip it. So you have complex 1, 3, and 4 that are able to pump the protons using the energy caused by the movement of electron taken by NADH. So you're gonna have a bunch of protons in this side, many of them. I'm gonna leave a few in the mitochondrial matrix. Okay, so you see, we have a significant number now of protons in the intermembrane space. So this is gonna make the intermembrane space the p side. What p means? Here it means positive. Positive because the protons have a positive charge, and this is gonna make the intermembrane space positive. On the other hand, the mitochondrial matrix is gonna have few protons compared to the intermembrane space. So this is gonna leave it like the negative side. Okay, we have all these protons in the intermembrane space, and the mitochondrial matrix have a few. What's next? Okay, the next part, I want to explain it with a little story. So imagine that you're in a party full of people. You just want to get out because there's so many people that it feels so crowded. So you want to go to a place that is less crowded. The protons are the same. They will move spontaneously down their electrochemical gradient, but to get out of the party, you need a door. For whatever place you are inside, you need to get out. The protons have that same thing. They cannot cross the membrane just like that. It's like trying to cross a solid wall. They need a channel to be able to pass from this side to this side. And that door, that channel, is gonna be ATP synthase. So ATP synthase is gonna allow the protons to cross, and by allowing them, the ATP synthase is also using the electrochemical gradient to be able to synthesize ATP from ADP and phosphate. So even if you don't have the electron transport chain, but you do have the proton gradient, you will still be able to synthesize ATP. And that's an important concept because that's what electron transportation is doing at the end of the day. It's pumping protons so ATP synthesis can occur. And we have seen this system in other things. Also, photosynthesis uses the same idea of having a proton gradient to synthesize ATP. The p side and negative side are different for them, but the general idea is the same. The p side is gonna be where the higher number of protons are, and the negative side is gonna be where the less number of protons are.